Hello friends, today we are looking to finish the 10th module of our course where we are talking about the biological effect of radiation. You definitely have gone through the first lecture by now, and actually I am having quite a bit of gap between the time I recorded the previous lecture and this one, as I was down a bit with fever and cough and cold, and even today also my voice is quite a bit restricted. Hopefully I can scrap through. But just to have a recap of what we have done in the previous lecture. First, you are introduced to the different units of radiation doses that we generally use, like just to associate with radioactivity. You are very early you were introduced to the units like Curie or Becquerel, which are associated with the radioactive disintegration. But when you are talking about the biological effects of radiation, we have to look for new units, and their units like Roentgen, Rad and Riem that came into picture, which are conventionally known as the 3 R's of radiation, or the SI versions of them, Gray and Sievert. So, you are introduced to those, and also several associated factors like different tissues respond differently to radiation. Accordingly, we use some kind of tissue weighing factor. These are introduced. Then you are introduced to the concept of linear energy transfer, which is actually some kind of potential or stopping power of a tissue against radiation, or against as different tissues respond differently, or the same tissue I can say responds differently to different particles depending on their mass and energy level, which is given a measurement about in terms of this LET. Then you are introduced to different sources of radiation. Living being can receive radiation from infinite number of sources, like we are always subjected to some kind of so called background radiation, which involves the cosmic radiations and the rays coming from the outside atmosphere. Also there can be radiative particles that are going interior to our body or inside our body through the foods that we are taking. There can be particles which are going with air during the inhalation process. And also nowadays, with increase in the medical equipments, there are significant fraction of radiation being contributed by different kind of medical instruments, like where instruments like MRI, which doesn't require any kind of radiation dose, introduces any radiation, doesn't introduce any kind of radiation effect. Very general or simple kind of technique like an X-ray can impose radiation equivalent to 11 days of natural radiation, whereas CT scan, which is again a quite common technology nowadays, that just one sitting of head CT scan can lead to radiation exposure to your body, which is equivalent to 365 days, that is one full year of natural radiation, or more than 13 days of flying. Of course, when you are flying or you are at a higher altitude, you are exposed to larger amount of cosmic radiation, and that is why flying also induces quite a bit of radioactive effect on our body. But these modern medical equipments which involves radiation like X-rays or any kind of scans, they also can have significant effect, and therefore we need to be very careful before undergoing any such kind of them. Then we have discussed about the biological effects of radiation and the cellular effect of radiation. We have seen the cellular effect of radiation can be of two types primarily. One is the indirect effect, which leads to the radical formation, as our cell primarily comprises of cytoplasm and water is the main component of cytoplasm. So, the radiation generally breaks the H2O molecule there, leading to the formation of several very dangerous kind of radicals, such as the peroxide, the hydroxyl, and also so called the superoxides. They all can have important effects or important detrimental effects on the cell. And there can be direct effect also, where the radiation can change the gene morphology or the morphology of the DNA itself. We shall be looking more into them in today's lecture. Now, the terms were introduced in the last lecture itself, but let us look a bit more into these two terminologies, that is, whatever biological effects radiation may have, they are generally classified into two categories. One is stochastic and other deterministic, or sometimes called the non-stochastic effect. The deterministic effect generally refers to those kind of phenomenon where or which appears only once a threshold dose of radiation is breached. That is, if the radiation exposure is less than the threshold, then you will not find any kind of effect, or only when the threshold is reached the effect becomes prominent. But once you have reached the threshold, increasing the dose beyond that keeps on worsening the effect. So, the behavior can be, means if we plot something like this, where effect on this side and the dose on this side, till if this is the threshold, then below this threshold you will not find any kind of effect, but above the threshold the effect keeps on increasing very, very sharply. Yes. So, this is what we call the deterministic effect. Deterministic effect generally are immediate effects or short term effects. Once the threshold is reached, they are guaranteed to appear, and also the threshold value actually depends upon the particular person or particular place which is subjected to radiation, because different person, or in fact the different tissues of the same person have different values for this threshold, and also which kind of effect is going to appear, accordingly the threshold is also going to vary. And any early effect, as I have mentioned, and most of the normal tissue late effects are deterministic or non-stochastic in nature. These are some typical values of the threshold corresponding to the deterministic effect. Like generally the genital organs are the most affected by the radiation, and as you can see here, when they are subjected to, say the testis is subjected to a single absorption dose of strength 3.5 to 6 SV, then that is actually a quite high dose, or a prolonged absorption of measuring 2 Siemens year, then that will lead to a permanent infertility. Ovary is even more sensitive. Generally the female genitalia is much more sensitive to the male genitalia, and that is why the value is even smaller, in fact 10 times smaller to this. The lens of eye, that is also very, very sensitive to this. When it is subjected to a radiation dose of something like 0.5 to 2 Siemens only, it can result to a milky of lens, whereas cataract formation may appear with a dose of 5 Siemens or greater than 0.15 Siemens here for prolonged radiation dose. And bone marrow probably is the most sensitive kind of tissue or sensitive kind of part of the body related to radiation effects. With a very relatively smaller radiation dose of only 0.5 Siemens, it can lead to the blood forming deficiency. So, and also these data are a bit old, but still very much valid. These are recommendation given by the well known ICRP, that is International Commission of Radiological Protections, who generally sets the standards for any kind of radiation based guidelines. Now, putting this in comparison with the stochastic effect, for stochastic effect there is no such threshold dose. So, stochastic effect, whether that will appear or not, that does not depend upon the magnitude of the radiation that the object is being subjected to. Rather, they are more likely with increase in the dose, or I can say that the severity of the stochastic effect does not depend upon the intensity of the dose, but as the dose intensifies, their appearance is more likely. So, we can't say that for this particular dose this kind of stochastic effect is going to appear or not, but of course, they are more likely. And also there is no dose above which stochastic effects are certain to occur. They may not at all appear, but also they can appear with quite a small dose, because generally the effect is cumulative. When someone is subjected to a quite small dose for a very prolonged period, then the stochastic effects can appear. But I repeat, if the strength of the dose is more, then they are more likely to appear, but the severity of the disease or severity of this effect has no relation with the strength of the dose. And stochastic effect actually concerns much larger or more catastrophic effects of radiation, such as the carcinogenesis and also the gene defects or DNA mutations leading to hereditary effects. So, stochastic effects are long term effects, and they are also quite difficult to spot, whereas deterministic or non stochastic effects are immediate effects and they appear once the threshold is breached. Now, we need to get some idea about the human cell cycle. Each human cell undergoes quite a few different stages of development. The first stage of importance is the G1 stage. Like shown in the diagram, there are principally 4 or 5 stages. Once the first stage is the G1 phase, which is the growth phase or growth phase 1, during which the cell grows, and at the end of this G1 phase it is ready to replicate the DNA. Then is the S phase, when the DNA replication happens. Then we comes to the G2 phase, where the DNA replication is already done. So, it makes further growth and ensures that it is ready for cell division. And then the most important one, the mitosis, during which the cell divides into 2. And cytokinesis actually is a follow up step of mitosis, sometimes called a part of the mitosis itself. Yes. And some cells may have an intermediate G0 stage as well, where many human body cells may exit the cell cycle and remain in a resting position or some kind of neutral position for some time. In fact, some cells may remain there for a very long time, and that is referred to as a G0 phase. Now, scientists have done some experiments to understand which particular phase of this human cell cycle is most vulnerable to radiations. And to facilitate that, what they have done, they have chosen different cell samples, and applying some kind of sophisticated techniques, they have ensured that their cell cycles are exactly following the same timings, that is, they are perfectly synchronous with each other. Once they have developed quite a few cell colonies which are perfectly synchronous with each other, then different cell colonies are subjected to different amounts of radiation and also in different phases of their individual cell cycles. And it has been observed that a cell is most vulnerable to radiation when that is going through the mitosis process or about to go through the mitosis process. When it is subjected to radiation in the other phases like G1 phase or S phase or early part of G2 phase, effect of radiation is quite small. But when it is going through the mitosis, then only it is most vulnerable, or it is about to start the mitosis somewhere here, then also it is very much vulnerable. And there is a reason also. Like we know that inside the cell there are different kinds of components. Now, if radiation affects some of the components, say if it affects the mitochondria may get permanently damaged, but inside a cell there can be several mitochondria, and therefore, just damaging one may not affect the cell performance too much. But once the radiation affects the nucleus, then the radiation is definitely going to be very important, and the cell is going to suffer, because nucleus is the main part of the cell and that is unique, and the nucleus is in the most vulnerable position when it is going through the mitosis. This is a very rough schematic representation of cell division, where both mitosis and meiosis are shown. Meiosis is the one during which the chromosomal exchanges happens, but that is not of our interest. Let us focus on mitosis only. There are principally 4 different phases: prophase, metaphase, anaphase and telophase, and sometimes also a 5th follow-up phase, the cytokinesis, which is more like a post-processing phase. During the prophase phase, the chromosomes are duplicated. This is where the chromosomes are duplicated. So, initially if there are n pairs of chromosomes, like if this is the parent cell where there are, in this diagram there are 4 chromosomes, the chromosomes are initially duplicated in the prophase phase, leading to 4 chromosomes, and now, or 4 pairs of chromosomes I should say, and then these chromosomes align each other along the metaphase plane during the metaphase process, and then they subsequently separated out to develop 2 new daughter cells during the anaphase getting completed during the telophase process. Accordingly, we get 2 different daughter cells which are identical to the parent cell. Mitosis is the most common type of cell division that we can see, and that is the one that is responsible for development of our body from a single cell embryo to a fully grown human body. So, if mitosis is affected by radiation, then there can be real catastrophe effect and something known as cell killing. Cell killing refers to reproductive death of a certain fraction of cell colonies when subjected to acute radiation. Like when a cell is affected by radiation, then the cell may lose its reproductive power, and accordingly it is terminology wise it is called the cell is being killed. That cell killing or causing the reproductive death, that depends upon the level of the dose. Again, experiments are conducted with different cell colonies being and subjecting them to different levels of radiation, and then observing what fraction of that has suffered this cell killing, and it has been found to be proportional to the LET again. Like in case of high LET radiation, it is a very sharp decline. You can see it is a vertical straight line which is going down very rapidly. Here one thing of importance here is the vertical scale is a logarithmic scale, and so the change is extremely rapid. Whereas for low LET radiation, the change is very small, particularly in this part there is very little change, it is increasing only later on. So, for a high LET radiation dose, the effect of for radiation causing the cell killing is very prominent. And now, this cell killing can be of 5 different types which are shown here. A cell when being subjected to radiation can follow different kinds of routes, all associated with several kinds of enzymes and chemical processes. One thing you have to remember here is that while we are talking about the effect of radiation on cell killing, actually all the effects are more or less chemical in nature, particularly the indirect effect of radiation, because a cell comprises of several kinds of chemicals, and as we have already seen, the indirect effect of radiation is to develop free radicals, and once the radicals are developed, then the next part is just chemistry. So, from that point of view, the effect after that free radical formation has taken place is the same as with any kind of chemical poisoning. So, the way the cell is going to react to a nuclear accident and the way it is going to react to some chemical accident, there may not be too much different. But of course, the fact is that for a nuclear accident the effect may be very prolonged, because the radioactivity may remain in the surrounding for a few hundred years as well. So, these are the 5 different kinds of mechanisms a cell may undergo: apoptosis, necrosis, senescence, autophagy and mitotic catastrophe. Apoptosis is a highly regulated mechanism of cell death. Distinct cytoplasmic and nuclear morphological changes are recognizable in cells undergoing apoptosis, such as shrinkage of the shell, contraction and membrane blebbing, nuclear condensation, fragmentation of the DNAs, and also cell destruction into membrane bound particles. So, apoptosis is the most common type of cell killing process. In fact, a body to replace the old cell by the new one also follows the apoptosis, but apoptosis is the first most prominent kind of effect, cell killing mechanism that radiation can lead to. Then is the necrosis. Necrosis generally is considered as a tumor cell death process that predominates after a high radiation dose treatment, while at a lower dose it has been indicated as a passive and unregulated event. One thing we have to understand here, all the effect of radiation may not be bad, because treatment of carcinogenesis or such kind of things also makes use of high dose radiations, and there the objective of radiation is to kill the affected tumor cells. So, necrosis generally is the primary mechanism there which leads to the cell killing. Then senescence. It is a known strategy during aging, and increase of senescent cells in older tissues or in radiation treated tissues may be responsible for some pathological onset. Radiation may induce accelerated cellular senescence, a state of irreversible growth arrest in which the damaged cells show altered functions and despite being vital are no longer competent for proliferation. So, cell is not able to grow any further and also not able to divide any further. It has been demonstrated that senescence is the principal response of some cell types at lower radiation doses, whereas at higher doses they may lead to apoptosis or in certain cases necrosis. So, these three are the primary types of cell killing mechanism that you can find when that is subjected to radiation. Apoptosis is the most common one, necrosis can also be found, but when the radiation dose is low, then the most common one that you will find is this senescence. But when the dose is high, it is more likely to be apoptosis or in certain cases necrosis. Autophagy is a basic catabolic mechanism that involves cell degradation of unnecessary or dysfunctional cell components. Again, it is a very natural process. The dysfunctional cell components are being eaten up by the cell itself or some other part of the body whose function is to clean the unnecessary portions, thereby cleaning the body itself. It has been described as an adaptive response to survival, whereas in other cases it appears to promote programmed cell death via non-apoptotic mechanism. And finally, MC or metabolic catastrophe. It is described as a cell death mechanism occurring during or after aberrant mitosis associated with various morphological and biochemical changes following radiation induced incomplete DNA synthesis. It can also be caused by chemical or physical stresses and represents an oncosuppressive mechanism to avoid geometric instability. It has been defined as a special example of apoptosis because it shows several biochemical features which are quite similar to apoptosis only. Now, as we have repeatedly mentioning that the way different tissues respond to radiation are not same. Of course, when a cell is subjected to radiation, particularly when it is about to go mitosis, that is very much likely to go for cell killing, that is reproductive death. However, that likelihood that is individual to the tissue itself. Based upon the radiosensitivity, tissues can be defined into or divided into three categories: highly radiosensitive, moderately radiosensitive and least radiosensitive. Highly radiosensitives are those which generally are very important tissues of the body and they are also affected strongly by the radiation. The most important one of them may be bone marrow. This is a picture of bone marrow being suffered by radiation. The lymphoid tissue can be there. The gastrointestinal epithelium is also very important, which actually forms the inner layer of our GI tract. Those cells are very active and they are going through continuous mitosis process. So, they are very likely to get affected by radiations. The gonads, I kept on mentioning repeatedly, they are also very much affected by radiation. Even small amount of radiation can also lead to permanent infertility for both male and female. The embryonic tissue, that is the fetus, that is also highly sensitive to radiation. The under moderately radiosensitive tissues, you can get skin. Skin is always subject to radiation, particularly the background radiation or cosmic radiation it is being subjected to. The effect of radiation on skin can be in the form of reddishness of the skin, appearance of small pimple kind of structures or rashes, etc., and can be even more severe depending upon what level of radiation it is being subjected to. This is a picture where you can clearly see here there are lots of disintegrations of the internal cells and in this part as well. Because of the effect of radiation, they is strongly affected. The vascular endothelium, lung, kidney, liver and also the lens of our eyes, they can also be strongly affected by radiation. But the parts which are very less affected, for most of the normal radiation doses they are almost immune to radiation. can be the nervous system. Thankfully, our nervous system is hardly affected by radiation, and therefore, even when someone is subjected to radiation for a prolonged duration of time, his nervous system keeps on working properly. The muscles, the heart tissues like muscles and bones and cartilage and several connecting tissues, they are also very less affected by radiations. This is a set of pictures which shows the effect of radiation on some highly sensitive tissues. This one is the normal picture of a bone marrow when it is not subjected to radiation. When it is subjected to radiation dose of 8 gray, you can see there are very less number of cells appearing, and when it is subjected to even higher radiation dose of 14 gray, the complete structure has changed, and accordingly most of the bone marrows have suffered the cell killing or reproductive death, not being able to cause develop newer red cells, and therefore may lead to leukemia. Small intestine, if it is a macroscopic view, then you can see with 8 gray of this, the muscles are corresponding tissues are elongated, and when it is subjected to a 14 gray dose, then these cells have already died, these tissues rather, they have already died and is severely affected. And if we take a microscopic view of the same thing, then you can see with 8 gray dose, they have already started to get affected. Their shape has got distorted, and also some of them, some discontinuity has started to appear in these zones. They have started to get separated from the base, and when it is much higher dose of radiation, they are completely separated from the base, and their shape is also extremely different from what we initially had. So, these are the effects radiation may have on highly sensitive tissues, and radiation can have even severe effects on the fetus or embryo, particularly during the first 8 weeks of pregnancy. You can see within first 2 weeks, if it is subjected to a dose of threshold dose of 50 to 100 milligray, then it can lead to the death of the fetus, whereas within 2 to 8 weeks with a threshold dose of 200 or 250 milligray, it can lead to congenital anomalies, growth retardation and childhood leukemia. For later part, the chances are much lesser, threshold also keeps on increasing, but there the effect of radiation primarily is not fetus death, but severe effects on the mental part. That is, it can lead to mental retardation, it can lead to intellectual deficit, or in severe mental retardation may also appear in the later part of pregnancy. And that is one primary reason that nowadays pregnant ladies are not suggested to go for X-rays. Earlier, X-ray was the most common mechanism that was used by the doctors to test the status of the fetus, but nowadays everyone is asked to go for ultrasound, because it is almost, the use of X-rays is almost banned for pregnant ladies. That is precisely to avoid these effects of radiation. Of course, ultrasound does not involve any kind of radiation effects, as that is a sound wave based techniques, and hence that is completely that can completely avoid any of these kind of effects. Then we come to the genetic effects of radiation. It should be genetic effect of radiation, not radioactive. Now, that is where we are talking about the direct effect. Direct effect refers to when the DNA structure is directly being subjected to incoming radiation, something like an UV photon or an IR photon. Again, that is very likely to appear during the mitosis process itself, because during other stages of the cell division or cell cycle, I should say, the DNA is not exposed. The DNA is kept inside the nucleus and it has very less chance to get exposed to the radiation. But during the cell division process, the DNAs are open, and that is why the DNAs may get subjected to radiation. And there can be several kinds of effects of radiation, and the primary effect can be the causing mutation to the DNAs, thereby completely changing the characteristic of the offspring who are going to come from that person. If the germ cells are subjected to such kind of radiation, generally they lose the power to reproduce. But if any of those germ cells which are affected by radiation, they are able to survive and then lead to the formation of a zygote, then there is a high chance that the next generation will be affected by radiation. There can be several kinds of effects that we can find. Very commonly the Down syndrome is one of the effects. We can have chronic myelogenous leukemia, or we can have also cystic fibrosis, we can have hemophilia, and we have essential hypertension. These are all different kinds of effects that may come because of radiation. Again, these effects are also similar to any other kind of genetic effects. Like we have mentioned, in case of indirect effect, the effect of radiation is to cause the radical formation, and then rest part is similar to any kind of chemical effect. Similarly, here also here radiation is causing a mutation to the DNA or causing a change in the structure of the DNA, and then next part is similar to any kind of genetic defects I should say. So, there are several models of gene theory that are available which tries to predict this, but still very less is known, and also these genetic effects of radiation are more stochastic type, that is their long term effect. It is very difficult to understand whether they are going to appear or not, very difficult to understand immediately whether they are going to appear or not. Only with observing over a prolonged period of time we shall be able to ensure that they are going to appear, particularly if the effect comes in the next generation, then that is quite difficult to correlate, because the defect can the effect or genetic mutation that is getting caused, that can be from any of the parents, can be from the father, can be from the mother, and how much effect is getting transferred, that is also quite difficult to predict. So, this takes us towards the end of this particular module. Actually, there are several other factors that could have been added here, and the length of the module itself is also quite short, but any further discussion that I would like to have about the effects of radiation it can have on human cells or on the DNA, that requires much more knowledge about the biology and also genetics, which I am not at all conversant with, and also that is not relevant to understand from the point of view of this course. That is why we are keeping this module quite short. Now, just to summarize the key points from this particular module, here you are introduced to specialized units for measurement of radiation exposure and doses, units like Stevens and Gray. Then living being can get exposed to radiation through several means. Role of medical diagnostic tools is increasingly dominant in worldwide population dose, particularly in technically advanced countries, like we have seen in 1980s, where medical instruments are contributing only a paltry fraction in total cumulative doses. In early 2000s, it is contributing nearly half of the total radiation dose in United States alone. Different human tissues respond differently to radiation, with the bone marrow and gonars being the most sensible ones, and also I should mention about the fetus. Indirect effect of radiation is the production of free radicals inside the cell and subsequent chemical effects. Direct effect can be the mutation of DNA leading to numerous genetic diseases. Deterministic effect of radiation is effective beyond a threshold dose, but once the threshold is breached, then the severity of the effect is directly proportional to the dose itself. Whereas the stochastic effect has no threshold, it may appear, may not appear, it is very difficult to predict, but larger the strength of the dose, the more likely are these stochastic effects, the appearance of these stochastic effects. So, that is all for this 10th module. This probably is the shortest possible module that we have in this entire course, because most part of the relevant discussions are related to biology and medical sciences, which I have tried to avoid in this. But something that I could have added rather, that is whatever we have discussed here are the bad effects of radiation, but there can be several good effects also. The use of radiation in cancer treatments or similar kind of other effects. Again, some medical terminologies or medical knowledge is required, so I have not gone there. And finally,
that something that I must have included, that is how can we get protected ourselves, can get ourselves protected from this radiation. Particularly from the very beginning of the course, we are repeatedly saying that whenever there is any discussion of setting up any nuclear power stations, the major discussion is to protect the surroundings from the dose of radiation. But whether that is at all important, or what kind of protection we should have in our nuclear power stations, but that discussions I have not put in this, because that will be the topic of our next week, where we are going to discuss about the safety and security of a nuclear power plant, and there we shall be starting with the discussion of how we can get ourselves protected from radiation itself. So, thanks to all of you for listening. If you have any query, please write to us. We shall be happy to answer you. Thanks a lot. Bye.